Good morning, everyone. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, the Science and Technology channel.
And we're talking about material today. Science and material.
Cool. Really cool. A new alloy could turn tomorrow's vehicle scrap into America's next manufacturing advantage. Where else can you do this but in the United States? A large influx of aluminum auto body scrap is expected to move through recycling systems over the next 10 years. Much of this material contains too many impurities to be reused safely in high-performance automotive components, which significantly reduces its value. But we've got this new technology. Would you like to know more?
Researchers at the Department of Energy's Oak Ridge National Laboratory have now developed a solution, a new aluminum alloy known as ridge alloy. This alloy allows low-grade scrap to be converted into material suitable for producing strong, reliable structural vehicle parts, creating a valuable domestic supply chain. So
I'll say, go to all the junkyards, get that scrap aluminum, get it to a place where you can melt it down and do this ridge alloy thing, and boom, you got a new industry. You know what I'm saying?
Yep.
Aluminum appears on the DOE's critical materials list because it plays a key role in technologies that generate, transport, store, and conserve energy. Ridge alloy is created by melting down post-consumer aluminum scrap and recasting it into a formulation that meets industry standards for strength, ductility, and crash performance. ORNL's that's the Oak Ridge Boys, long-standing leadership in aluminum alloy research enabled the team to use a focused design strategy that sped up the development.
Quote, the team advanced from a paper concept to a successful full-scale part demonstration of a new alloy in only 15 months. This is according to Alan Haynes, director of the ORNL's Light Metals Core program. Going on with the quote, that's an unheard of pace of innovation in developing complex structural alloys, unquote. Okay.
Aluminum heavy vehicles began entering the U.S. market around 2015 with Ford's F-150, among the earliest to be widely produced. A lot of them are produced. By the early 2030s, many of these vehicles will reach I have an F-150, a Lightning electric vehicle, and it's aluminum, the shell, the outer. Many of these vehicles will reach the end of their lifespan, generating as much as 350,000 tons of aluminum body sheet scrap each year in North America. Instead of returning as high-value material, much of this scrap is expected to be downgraded into low-grade castings or shipped overseas, representing a lost opportunity for domestic manufacturing.
Yeah, keep that stuff here.
Yeah.
Okay, another quote. You can repurpose post-consumer aluminum into something non-structural like engine blocks, says Alex Plotkowski, ORNL group leader of computational coupled physics. Going on with a quote, but it won't have the properties needed for higher value, structurally sound body applications. Okay.
The main issue is contamination. During the shredding process, scrap picks up impurities such as iron from fasteners and mixed components, creating unpredictable and weak chemistries that are unsuitable for commercial structural alloys. As a result, most high-strength vehicle parts continue to rely on primary aluminum, which requires raw ore and a high energy-intensive production process.
While primary aluminum is mostly imported, the U.S. has some of the world's best infrastructure for vehicle shredding and aluminum scrap recovery. Quote, using remelted scrap instead of primary aluminum is estimated to result in up to 95% reduction in the energy needed for processing a part. That's according to Amit Shyam, leader of ORNL's Alloy Behavior and Design Group. Okay.
To make that possible, the team applied world-class scientific tools such as high-throughput computing, probably AI, which involved more than 2 million calculations to predict the optimal alloy compositions with targeted properties, as well as materials characterization and neutron diffraction at Oak Ridge Boys Spallation Neutron Source, a DOE Office of Science user facility. These tools help the researchers understand how specific impurities affect alloy behavior. Neutrons are uniquely suited for this kind of research because they can penetrate deep into dense metals without damaging the material, allowing scientists to observe internal structures and atomic scale changes.
That 2 million's got to be AI, right?
Yeah.
That's a lot of computation. So anyway, after pinpointing the desired blend through rapid computational predictions and laboratory trials, the new alloy was tested in a real-world environment. PSW's group Trialco Aluminum in Chicago supplied recycled aluminum ingots, metal blocks ready for remelting, cast from mixed auto body sheet scrap, and tailored to Ridge alloy specifications. The ingots were shipped to Falcon Lakeside Manufacturing in Michigan, where they were successfully cast into automotive parts using high pressure die casting. I mean, there's a lot of stuff that's aluminum now.
Yeah.
On a car.
The part we chose was medium-sized and moderately complex, Plotkowski said. The ultimate goal is to eventually cast larger parts, perhaps even automotive gigacastings, but this is the first step. The cast parts confirmed that Ridge alloy, consisting of aluminum, magnesium, silicon, iron, and manganese, had the combination of properties necessary for structural vehicle castings, even when made from recycled blends with higher iron and silicon content. Go ahead, Scott.
Quote. What?
No, it delivers. Go ahead and do that paragraph. It's a long paragraph.
You want me to wait a minute? You want me to finish?
Yeah.
Okay. All right. And then, all right. It delivers strength, corrosion resistance, and ductility, enabling the production of structural castings of unibodies, I didn't even think about that, frame components, and other critical parts from post-consumer aluminum scrap. This breakthrough offers the important opportunity to reshape the value equation of how North American auto body sheet scrap is sorted and used. Do you want me to read that next one?
No, I'll take it. I wonder how much of a NASCAR racing car is aluminum. I mean, because you want to be lightweight so you can go faster, but you don't want to fly off the track, because you don't have enough weight to grip,
Well, and again, I don't know what the cracking point of or the failure point of aluminum is. Is it worse than iron or steel?
Well, they've got these other things in it, the manganese and the silicon and the iron. So I would think that helps make it stronger.
Okay.
Quote, This team figured out how to take full advantage of a national lab's world-class suite of capabilities to rapidly fill a huge gap in our understanding of lightweight automotive materials, Haynes said. By the early 2030s, Ridge alloy could enable recycled structural castings at volumes equal to at least half of the annual primary aluminum production in the U.S. This would reduce energy use, cut costs, and strengthen domestic supply chains and create jobs, a whole new industry.
Yeah. All right, we're going to end here with a quote. Ridge alloy offers the first technology capable of recapturing the value of a fast approaching and historically massive wave of domestic high-quality recycled automotive aluminum sheet alloys. This is according to Haynes, who we talked about earlier. That's the picture. That's the big picture supply chain impact our team aimed for. There is also potential for future applications in industrial machinery, agricultural equipment, aerospace, mobile power generation equipment, off-road vehicles such as snowmobiles, motorcycles, and marine vehicles, including jet skis.
I'll bet you could use it for like a habitat on the moon, or the structural components for that on Mars. Why not?
Yeah. Bust it wide open. It's a new industry, like you said. Pretty cool.
In the U.S., we can do it. We can think it. We can do it.
Yep. All right.
All right, friends. We'll see you this afternoon.
Yes, sir. Thank you. Take care.